to my YouTube channel. Today the topic is bathtub curve. But before we start, if you are new, so don't forget to subscribe and press the bell icon. A component failure is most likely when the component is new. In the first month of use, the chance of the component failures is relatively high. In the first month of the use, the chance of the components when the failure is relatively high. Sometimes a component doesn't even work at all when the unpacked for the first time. This is called the DAO component, dead on arrival. When a component still works after the finished first month, it is likely that it will continue working without failure until the end of its technical life cycle. This is the other end of the bathtub. The chance of the failure rises suddenly at the end of the life cycle of a component. Environmental issues are discussed here, which is also the challenge of availability systems. Environment issues can cause the downtime as well, and with power and cooling and external factors like fire, earthquakes, flooding, and can cause the entire data centers to fail. Power can fail for a short or a long period of time, and we can have the voltage drops or spikes. Power outages can cause the downtime, and power spikes can cause the power supplies to fail. The effect of these power issues can be eliminated by using uninterpretable power supply UPS, and more information on UPSs can be found in the sections. Failure in the air conditioning systems can be lead to the air temperatures in the data centers. When the temperature rises too much, system must or will automatically be shut down to avoid the damage. Next, we discuss the complexity of the systems. Adding more components to an overall system design can determine the high availability even if the extra components are implemented, and then the actual high performance availability are these process in which. And the paradox, this sounds like the paradox, but in practice I have seen such situations. Complex system inherently having more potential points of the failure are more difficult to implement and correctly. Also, a complex system is harder to manage. More knowledge is needed to maintain the system, and errors are made more easily. Sometimes it is better to just have an extra spare part in the closest than the use of the complex redundant systems. When our workstations fails, most people can work on the another machine, and the defective machine can be swapped in 15 minutes. This is probably a better choice than the implementing the high availability measures in the workstation, like the dual network cards, dual connectors to dual network switches that can fail over, and failover drives for the network card in the workstation. Dual power supplies in the workstation fed via two separate cables are power outlets on two fuse boxes, etc. You get this point. Are you getting this point? By the same goes for the high availabilities, and then over the process of the high levels. I once had a very instantable set of redundant ATM asynchronous transfers mode and network switches in the core of the network. I could get to the system's failover reliabilities by multiple instances of the downtime of a few minutes each. When I remove the redundancy in the network, we will discuss in this topic and in this passage. The two passages are even. When the redundancy, I removed the redundancy in the network never failed again for at least a year. The leftover switches were loaded with a working configuration and put in the closest. If the core switch would fail, we would swap it in the 10 minutes, which give that this would be happen not more than the once year. Probably even less led to an availability of the least 9.99.995%. Again, we discussed the complex systems and sometimes its patterns, and I all told in this paragraphs we will discuss the how the system worked in the passage of the downtime environment, and then it all slice the workstations via the separate cables. But outlets the sum goes of the high availability covers which are discussed here, they experienced. Thanks for watching my video.